Not quite. Have you ever stood on the ground and wondered what's beneath your feet? Not just a few feet down, where you might find pipes or tree roots, but miles and miles below. What secrets does our planet hold in its deepest layers? For most of human history, that question was the stuff of fiction and fantasy. But in the 20th century, a group of scientists decided to find out for real. They set out on an audacious mission to drill as deep as humanly possible, piercing the Earth's crust. This grand experiment took place on the remote Kola Peninsula in Russia, a cold, desolate landscape near the Arctic Circle. The result was the Kola Superdeep borehole, a man-made hole stretching an astonishing 12,262 meters straight down. That is over 12 kilometers, or 7.6 miles, deeper than the deepest part of the ocean. This incredible project was not about finding buried treasure or lost civilizations. It was a pure, scientific quest, a journey driven by the fundamental human desire to know. What is our planet made of? How did it form? What happens to rock under unimaginable pressure and heat? These are the kinds of questions that keep scientists up at night. The endeavor began in 1970, a time when the Soviet Union was locked in a technological race with the United States. While the Americans were looking up, aiming for the moon and the stars, the Soviets decided to look down into the very heart of our own world. Science became an arena for national pride and ideological competition. The space race dominated the headlines, rockets, orbital mechanics. But another quieter race was unfolding, one aimed not at the heavens but at the Earth's mysterious interior. The Soviet Union, a powerhouse of scientific and industrial might, embarked on a project of unprecedented scale. The plan was formally initiated on May 24, 1970, with the objective of drilling as deep into the Earth's crust as technology would allow. The stated goal was to reach a depth of 15,000 meters. The location chosen for this monumental undertaking was the Kola Peninsula, a finger of land pointing into the Barents Sea and the White Sea. The peninsula sits on the Baltic Shield, a vast area of ancient rock that is among the oldest and most stable on Earth. By drilling here, scientists hope to reach the Konrad discontinuity, and perhaps even the Mohorovicic discontinuity. Drilling a hole over 12 kilometers deep is not like digging a well in your backyard. It requires specialized, incredibly powerful equipment capable of withstanding conditions that would destroy ordinary machines. The Soviets developed a unique drilling rig, the Uralmash 4E, the Uralmash 15,000, specifically for this mission. This wasn't a simple drill that twisted a long pipe from the surface. That method would be impossible over such distances. The friction and torque would be too great. Instead, they devised an ingenious solution. The drill bit at the very bottom was the only part that rotated. It was powered by the flow of high-pressure drilling mud pumped down the long, hollow drill pipe. First, it acted as a hydraulic motor. Second, it cooled the drill bit. Third, it carried the crushed rock fragments back up. The journey began, meter by painstaking meter. For the first few kilometers, the drill chewed its way through rock that was relatively familiar. The core samples were composed primarily of granite and gneiss. Gneiss is a metamorphic rock, formed under intense heat and pressure. As the drill bit descended, the scientists confirmed the geothermal gradient. At 3 kilometers, temperatures reached around 50 degrees Celsius, noticeably warmer than the Arctic air at the surface. The data refined how heat flows through the crust, impacting plate tectonics and mineral deposits. But the rock was surprisingly porous and fractured, and these cracks were filled with ancient water. As the borehole pushed past the 5,000-meter mark and headed towards 8,000 meters, the scientists entered a truly alien realm. The pressure was immense, squeezing the rock with unimaginable force. The temperature climbed steadily, making the environment hostile to man and machine. Familiar granite gave way to metamorphic rocks, telling a story of ancient upheavals. One startling finding: enormous amounts of water. The rock was saturated. Pressure squeezed water out of rock crystals. Water, other fluids, and gases formed a highly reactive chemical environment, a hidden subterranean hydrosphere. Seismic data predicted a sharp transition near 7 kilometers, the Konrad discontinuity. But the transition never appeared. Granite continued, though altered. Reflections likely came from heat and pressure effects, not a change in rock type. At this depth, strange acoustic phenomena were recorded. Most were machinery and rock fracturing. Some recordings were eerie and fueled the sounds of hell myth. Verstände Datsun Somber Burtsaumam. Breaking the 10,000-meter barrier was a monumental achievement. The drill was now deeper than the height of Mount Everest. Down here the environment became extreme in every sense. Pressures soared, rock behavior shifted from brittle to plastic. It would deform and flow, frustrating progress. Samples dated to over 2.7 billion years. A shocking discovery. Lots of hydrogen gas. The returning mud was described as boiling with it. Its origin is debated, but it proved the deep crust is chemically active. Rocks were heavily fractured and saturated with hot, mineral-rich water. The borehole became unstable. Plastic rock slowly squeezed in, threatening to trap the drill string. Equipment failed as limits were exceeded. Each meter was a hard-won battle. From over 6,700 meters, scientists found fossilized microscopic organisms, about 24 species of single-celled marine plants preserved in ancient rock, encased in organic compounds that survived incredible heat and pressure. It proved life existed far earlier than thought, with traces preserved deep in the crust. The discovery hinted that life, or its building blocks, might persist in extreme environments. Water, methane, hydrogen, and other gases created a potential chemical soup for extremophiles. No living microbes were confirmed at the greatest depths, but it opened the door to a vast, hidden deep biosphere, and to searching other worlds. Then came the heat. At 12,262 meters, it was about 180 degrees Celsius, nearly double what models predicted. The deep Earth was hotter, wetter, and more dynamic than imagined. The dream of reaching 15,000 meters died at a temperature of 180 degrees Celsius. Heat far beyond expectations became an insurmountable obstacle. Bits broke after only hours, electronics malfunctioned and fried. The 12-kilometer steel string risked warping and snapping. Drilling mud lost effectiveness at extreme heat. The rock behaved like hot clay, threatening to close the hole. In 1989, after reaching record depth, a portion of the drill string twisted off and was lost. They restarted from 7,000, but the heat remained. Progress crawled, risks and costs soared. Then the Soviet Union collapsed, funding and drive vanished. Drilling stopped in 1992. By 2005, the site was abandoned and capped, the deepest hole ever dug, sealed. Though it never reached 15,000 meters, the Kola Superdeep borehole was anything but a failure. It stands as a landmark achievement that reshaped our understanding of the planet. Its legacy is measured in the knowledge it brought to the surface. The crust is fractured, wet, and chemically active. Seismic interpretations required revision. The rocks below defied neat models. Thousands of meters of cores remain a priceless resource studied worldwide. Deep microfossils opened the field of deep biosphere research. Unexpected heat reshaped models of heat flow, volcanism, and plate motion. Technologies pioneered here advanced drilling, alloys, and downhole instruments for energy and exploration. The Kola borehole is a monument to human curiosity. We push into the unknown, across the cosmos, and into the hidden depths of our own world. What other secrets lie even deeper, and who will be next to find out?